Hi, in this video we are going to discuss about the various testbed temperature and testbed pressure sensors which are important during engine testing and engine calibration activities. Hence, we will be discussing first sensor location and their global nomenclatures. Second, correct location of their installation. It means at what location they should be installed within the system. And the last, different type of sensors like RTD sensor, thermocouple sensors, absolute sensor and gauge sensors. So let's start with the complete layout of testbed sensors. The green line shows the flow of fresh air going into the engine, while the red line shows the flow of exhaust gases coming out of the engine. Initially, engine breathes fresh air from the ambient or surrounding. So, it is very important to capture the ambient temperature and pressure. The temperature and pressure of ambient air are known as T0 and P0. The location of these both sensors is very close to the intake of air filter because we want to capture the temperature and pressure of fresh air which is going into the air filter. Moving on, after air filter, again we need to capture pressure and temperature. These are known as T1 and P1, and these sensors needs to be located within 150 mm of air filter outlet. The reason for capturing the temperature after filter is to analyze the effect of engine's compartment heat over the fresh air, because air filter and compressor inlet are connected by the help of inlet hose, which are made up of either metal or rubber. Hence, the effect of surrounding heat can impact the fresh air temperature. So, that is why capturing the T1 is very important. Talking about P1, we need to capture the pressure drop across air filter. Since air filter is a filtering device which is used to filter out debris and foreign particles from fresh air. So, it creates a drop in fresh air pressure. Hence, it is very important to capture P1 to analyze the status of an air filter. The value of P1 directly indicates whether your air filter is healthy or it is choked. The location of sensor should be within 150 mm of air filter, because if sensors are located near to the compressor, because of heavy suction by the compressor, we will have deviated pressure results. So, to avoid compressor suction effect, pressure sensor, which is P1, needs to be installed close to the air filter outlet. After this, fresh air reaches compressor housing and get pressurized. So, to measure the pressure and temperature of pressurized air, we need to install T2 and P2 between compressor outlet and intercooler inlet. They can be installed anywhere between these two components, which are compressor and intercooler. These sensors gives an idea about the functionality of compressor and gives a check on desired output, like the boost pressure. Now, pressurized air passes through intercooler and pressure and temperature of air drops down. Because intercooler is a heat exchanger, so it will reduce the temperature of the pressurized air. Hence, we need to capture the temperature and pressure after intercooler, and this is known as T2- and P2-. Significance of T2- is to monitor the reduction in temperature of pressurized air, because this air will go into the engine and can affect the volumetric efficiency of your engine. And P2- is important to check the pressure drop across intercooler. Pressure drop across intercooler is not desirable, but because of its design, there is always a pressure drop between 20 millibar to 100 millibar depending upon design of intercooler and the pressure of air. After capturing T2- and P2-, the fresh air passes through throttle body and goes into the intake manifold of the engine. One sensor which is controlled by engine ECU or engine control unit is installed over the intake manifold, which measure both temperature and pressure of air within the intake manifold. This sensor is not shown in this layout because that sensor is not a testbed sensor. It is an ECU sensor. Hence, by the help of that sensor, ECU will understand the properties of air within intake manifold, and by using the throttle body opening percentage at that instant, ECU calculates the amount of airflow. In case HFM sensor is not installed in your engine. Now, after combustion takes place, the hot exhaust gases comes out from exhaust manifold. Now, we need to capture the temperature and pressure of exhaust gases right after the exhaust manifold, or if possible at the outlet of exhaust manifold. These are known as T3 and P3. After this, the exhaust gases reach to turbine housing of turbocharger and rotates the turbine while losing the pressure and temperature of exhaust gases, because heat energy is getting converted into the rotational energy. Hence, the temperature and pressure of exhaust gas is reduced. The T4 and P4 are used for capturing temperature and pressure after turbocharger, and they should be located within 150 mm of turbocharger outlet. Significance of capturing T4 is to get an idea of heat energy consumed within the turbocharger, and for the selection of the material of the exhaust setup of the vehicle. And pressure value, that is P4, is very important because it gives the actual back pressure value of the exhaust system. When exhaust comes out of the exhaust manifold, it should be open to atmosphere, but we need to use exhaust gas treatment devices or EGT devices and muffler in order to reduce tailpipe emissions and tailpipe temperatures. Hence, these additional system creates hindrance in the flow of exhaust gases. So, P4 is used to capture the back pressure offered by these systems. If back pressure is very high, then it will lead to reduction in power output of the engine because of the two reasons. First, high back pressure will increase the pumping losses of engine during exhaust stroke. Second, proper scavenging will not take place, hence the combustion of your engine will get disturbed. Ultimately, we are going to lose the power output of your engine. So, to keep a check on exhaust back pressure, P4 is measured. After turbocharger, exhaust gas treatment devices are installed like catalytic converter and gasoline particulate filter or GPF. We need to capture temperature and pressure before EGT, that is T5 and P5, and after EGT also, which is T6 and P6. Temperature before EGT helps in determining the working behavior of the catalytic converter. Since the reaction within catalytic converter are exothermic in nature, hence the temperature after catalytic converter will be more if proper conversion of exhaust gases takes place. But in starting, before temperature will be more than the after temperature. It means the T5 will be more than the T6 because initially catcon will absorb the heat energy from the exhaust gases for its self-heating. But once catcon attains its light off temperature, the outlet temperature, which is T6, will be more than T5. P6 and P5 gives an idea about the porosity of catcon. While calibration, sometimes catcon gets burned. Hence, P6 and P5 will indicate the drop or rise in pressure across catcon or GPF. Hence, P5 and P6 are very important during the engine calibration. Sensor before and after EGT shall be located close to EGT to get the more accurate results and to reduce the effect of surrounding environment. After this, the exhaust gases passes through muffler in order to damp the pressure waves present within it, and the outlet of muffler is open to atmosphere. Hence, we use T7 and P7 just at the outlet of muffler to measure the tailpipe gas properties just before getting released into the ambient. P7 is not important because it will be almost similar to the ambient pressure, but temperature is very important, which is T7. Hence, in nutshell, we have T0, T1, T2 and T2- temperature sensors in intake system, while T3, T4, T5, T6 and T7 temperature sensors in exhaust system, and same for the pressure sensors. Apart from intake and exhaust system, we need to capture additional data like of coolant and lubrication oil. Hence, T oil and P oil are used to capture temperature and pressure of lubricating oil. These sensors are very important because lube oil properties determines the performance of an engine, and proper pressurized lubrication system helps in reducing friction between engines rotating and reciprocating parts. P oil needs to be captured after oil pump because this is the pressure of oil at which oil will start flowing into engine, but location of T oil can be either same as P oil or it can be the bottom of oil sump, or we used to call as drain plug. Drain plug location is more accurate because it gives the correct temperature of engine lubrication oil. After oil sensor, now it's time for coolant sensors. After circulating within engine, the coolant flows out of the engine towards radiator or cooling conditioning system. Hence, TW out and PW out needs to be captured right after the coolant leaves the engine. This is important because it gives an idea about the safe operation of an engine. After radiator, right before coolant entry into the engine, again pressure and temperature of coolant shall be measured, which are TW in and PW in. WIN stands for water inlet, while W out indicates water out. Moving on, the temperature of coolant TW out and TW in should have maximum difference of 10 degree during engine running and if the thermostat is open. This 10 degree ensures efficient cooling conditioning system. If this difference is more than 10 degree, then the cooling system is not efficient. It is overcooling the engine and we will lose the power performance. For example, the TW out is 85 degrees Celsius and TW in is 65 degrees Celsius. We can see there is a 20 degree difference because of the radiator. If this 65 degree coolant will go into the engine, then it will consume or absorb more heat from the combustion chamber. Hence, ultimately the power output of your engine will be less. Hence, to avoid the overcooling of the engine, your cooling condition system should be efficient, and to make it efficient, the temperature difference between TW out and TW in should not exceed by 10 degrees. The significance of PW out and PW in is to ensure leak proof system. It is very important to have a pressurized leak proof cooling system because it increases the boiling point of the coolant. Hence, we will have more efficient coolant conditioning system. Now, after learning about various nomenclatures of temperature and pressure sensors, it's time to learn about the various type of sensors and where to use them. Starting with temperature sensor, there are two type of temperature sensors which are used in engine test bed. First one, RTD, which is resistance temperature sensor. These are used in case of maximum temperature of 200 degrees Celsius. Second one, thermocouple type. Thermocouple temperature sensors are used in case of temperature up to 1200 degrees Celsius. During engine testing, RTDs are widely used for capturing T0, T1, T2, T2-, T-oil, T-water out and T-water in. While thermocouples are used in exhaust system like T3, T4, T5, T6 and T7. So, where the temperature range is up to 200 degrees Celsius, the RTD type sensors are used because these are far economical as compared to thermocouple. But in case of temperature above 200 degrees, then we have to go for the thermocouple sensors. Talking about pressure sensors, we have two type of pressure sensors. First one, absolute sensor. Second one, gauge sensors. Gauge sensors are made to capture pressure above atmospheric pressure, and absolute pressure gives the actual reading of pressure within a system. Generally, gauge pressure sensors are used in engine testbed for measuring pressures like P2, P2-, P3, P4, P5, P6, P7, P-oil, P-water out and P-water in. But for P0 and P1, we have to use absolute sensors because P0 will capture the atmospheric pressure and P1 is capturing the pressure drop across air filter. Hence, P1 will be less than the atmospheric pressure. Hence, P0 and P1 are the only two absolute pressure sensors. One important tip about pressure sensors. Pressure sensor for air is different from pressure sensors used for measuring oil and coolant because of their constructional difference. If air pressure sensor is used for the measurement of oil pressure, then it may damage the diaphragm of the sensor and ultimately the sensor will be damaged. So, while installing the pressure sensors, it is very important to confirm whether the pressure sensor is suitable for measuring the air pressure or coolant or oil. So, that's it about the various sensors of a test bed, their global nomenclature and their location. We will meet in the next video.